So far, we have looked at motion going this way, this way. We've looked at motion going up and down. We've been stuck in one dimension. This chapter, we're breaking free. 2 dimensions, baby. No, buddy. But we need to do a little bit of review of stuff before we actually embark. So, do a little reviewing. So, we're going to add and subtract vectors today in one dimensions, apply one-dimensional vectors to resultant velocity scenarios, and calculate the sides of and angles of right triangles. Yeah, baby. Okay, you've seen this slide before. The resultant just means the sum or the total or the net. Okay, when I say find the resultant, that just means the total. Okay, so we've seen this before. 7 to the right plus 3 to the right gives you 10 to the right. 7 to the left plus 3 to the right gives you 4 to the left. 5 up plus 4 down gives you 1 up, and 4 down plus 5 down gives you beautiful. Okay, now we have done this type of math when finding the net force, right? That's like the whole point of the free body diagrams. We just draw the forces, find the net force. Okay, we can apply this type of math to anything that's a vector. So at the moment, we have 4 vectors that we know of in physics. We have displacement, velocity, acceleration, and force. All 4 of those we can add together like this, find the resultant. Okay, now quick little warning on that statement. You can't add like force plus velocity. You can't add things that have different units. Just like in math class, like can you add those two? No. Okay. Only when they have the same variable can you add them, and then you can add them. Right? Okay. In the same way, you can't add like force and velocity or displacement and acceleration. They have different units. Okay. But you can add acceleration plus acceleration. Okay. So we're going to look at one application is in terms of velocity. Tell your neighbor. Okay, so we're flying a plane on a windy day. So you have 200 meters a second going that way, and you have 40 meters a second going that way. The resultant velocity is you simply add them together because they're going in the same direction. So you get 240 meters a second to the east. So that was flying with the wind. You have a tailwind is what they call that. Tell your neighbor. Okay. So this this actually happens when you're flying. So weather patterns typically go from the west to the east in North America. Okay. So if you're ever flying westward, it's going to take you longer because you're going against the wind. Versus if you're ever flying eastward, typically it takes you less time because you have the tailwind. Cool with that? What is the resultant velocity of the bird? Zero. The bird is flying the same speed that the wind is blowing. Good with that?
I got a Chromebook for Michael Larson.
You do. Awesome. Thank you. Oh, do you need to swap something out?
Mike. Thank you.
You're welcome. Thanks to 3 guys. We'll help him.
We've been making rounds.
Yeah. Tell your neighbor. Have you ever been swimming in a river? Okay. This river you want to get out of because it's owning you. It's like, okay. Good at that. Okay. So upstream, downstream. So if the current's going this way is downstream, this way is upstream. Just some terminology. Just you haven't heard of that before.
Can an object shot backwards while traveling forwards ever drop straight to the ground? It's a fascinating thought, but trying to prove it is bringing our physics team unraveled. Tori, Carrie, and Grant are struggling to prove the supposedly common sense myth that an object drops straight to the ground when its forward and backward momentum are exactly the same. With the forward and backward momentum matched as close as they're going to get it, the pressure's on Grant for a perfect release.
I don't know about you guys, that look pretty good to me. Let's check the high speed.
It really looked good to the naked eye, but the judge in this case is the high speed.
Oh my God, it's like a cartoon. It's just in the air, it stops, and it just falls.
Look at that. Fantastic. I mean, look, it doesn't move at all. It's going straight down.
Woo! We did it! We did it! Yeah! Vector edition! Woo!
Okay, good with that? All right. So, pretty sure I think we talked about this. Okay, a minus b, you can write that how? A plus a negative b. Okay, what do we do when we make a vector negative? Goes the other way. Flip it 180 degrees, goes in the opposite direction. Good with that? Okay, is a minus b the same thing as b minus a? No, so be careful. That's a subtraction sign. Thumbs up when you have a guess. Have a conversation. All right. I hear a lot of different answers. In math class, here's how they would teach this. Negative 2 minus 6 equals what? Specifically, positive 6. Be equal to a negative 8. You okay with that? Here, it's the same problem. I'm just going to show it in a little different way. Which one are we applying the negative to? The 6. So we say plus a negative 6. I'm going to flip this. Does that make sense? The negative flips that, makes it go in the other direction. So I have 2 to the left, a 6 to the left gives you 8 to the left. Good with that? Try that one. Tell your neighbor.
We had a solid debate on this one. And then it's like, you're going to.
Correct answer is? Correct answer is B. Good with that. You make the green arrow go down because we're applying the negative to A. So it's 5 down plus 12 down gives you 17 down. Good? You know what? Go ahead and tell your correct answer is B. Next question. Tell your neighbor. Correct answer is A. Change in velocity is final minus initial. Okay. Final is negative 2 meters a second minus initial positive 3 meters a second. The change in velocity, negative 5 meters a second. Thumbs up when you have a guess. Have a conversation. So we're saying up is the positive direction.
Oh wait, yeah, no. Equals 2. X equals. Wait, yeah. I was doing initial.
Correct answer is? Correct answer is D. Final positive 10 minus initial negative 10. Good with that? Tell your neighbor. Okay, is everybody good with the bouncy ball experience? A greater change in velocity. Change in speed is different. Okay, change in velocity. You went from 0 minus -10, positive 8 minus a -10. This gives you plus 18. This gives you plus 10. Good there? All right. Do a little trig review. I'm hoping all this is in there already. But if I just assume so, that usually doesn't go well. So that is why we're doing this review. Okay. So in physics, we like theta. This is our variable, our go-to variable for an angle. Okay. Sine, cosine, tangent. Hopefully you've had this memorized already because they made you memorize this in math class. Okay, so sine is equal to opposite over adjacent. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Okay. What type of triangles can we use these for? Right triangles. Those that have a 90 degree in there. Okay. Now, these labels come from describing these sides relative to whatever angle we're looking at. So when we say opposite, we mean the side that is opposite of this triangle. Thank you very much. It sure is. That would have been catastrophic. Make sure you change that in your notes if that was rough. Thank you, Sophia. Thank you, Starlet. All right. So opposite is saying is the side that is opposite of this angle. Okay. When we say adjacent, adjacent means touching. Well, there's two sides that are touching this angle. How do you know which one it is? Well, one of those two is the hypotenuse. The hypotenuse is always the side that is opposite of the right angle. It's always the side that is the longest of the sides. So that's my hypotenuse. Therefore, this leaves that to be our adjacent side. Okay, that's where those you get those labels from. Okay, so right triangles also have. You can also use Pythagorean theorem. So using the labels adjacent and opposite and hypotenuse, write Pythagorean theorem with those rather than a squared plus b squared equals c squared. You can just do it in your mind if you want. So it could be adjacent plus opposite, adjacent squared plus opposite squared equals hypotenuse squared, or it could be opposite squared plus adjacent squared equals hypotenuse squared. The important part is that C is the hypotenuse. Okay? So, get out a calculator. Correct answer is sorry, I should have said thumbs up when you're ready to roll. Tell your neighbor what equation you're using. What did you use? What equation? Which equation did you use? Pythagorean theorem. Correct answer is C. Okay, go to that. Then 139 subtract 25 gives you 144. Take the square root of that, 12. Good? All right. In physics, we like degrees. Pre-calculus likes radians. So if you're in pre-cal, there's going to be a conflict of interest. Okay? So you're always going to have to make sure before you walk into this class and before you walk into pre-cal that your calculator is set to the correct mode. We like degrees. On your calculator, there should be a DEG or a D in like a small and fine print somewhere on your screen. If it has R or RAD, that's radians, you need to switch that. The way you switch that, there's a mode button. Some calculators, these type of calculators, have a DRG button. You just press that repeatedly, scrolling through it until it's the right one. Or no, you just hit that and then select the right one. But mode, sometimes it's like a second, but you want degrees. Okay. If you don't have a calculator and you're using your phone, you need to download a scientific calculator app, I think. Depends on what your default calculator is. Okay. So once you have discerned if you're in degrees, then go ahead and do this problem. And if you're not sure, call me over and I will make sure your calculator is functioning in the proper mode.
She told me how to do it, but I forgot.
You go to mode.
Yeah, and then.
And so you're going to do shift mode. You're in degrees right now. Oh no, you just type 3.
Okay.
So there's your alternative is radians. And you got D up top.
Okay, thank you.
No. It's an 89. Oh no, 84. Yeah. So then just scroll down one more. Right. Oop.
Sorry.
Yep. Enter. There you go.
Okay. Thank you.
Welcome.
Why have you put this?
Anybody else? Between radians and degrees? No, you. Oh yes, you. No, you won't. You did? No way. Just do that again completely. 5 times.
Oh.
Oh, sure. That's fine. See?
Oh, okay.
Okay, correct answer is? Well, let's talk through it. What sides do you have? You have the hypotenuse, and you're looking for the opposite. It's opposite of this angle. So we're going to use what? Sine, cosine, tangent. We're using sine. Does everybody follow how? Okay. That needs to be memorized, that sine, cosine, tangent. When I was in high school, they're like, just remember Chief Sokotoa. I'm like, that doesn't help. I don't know how to spell very well. Like that is there's mnemonics. There's like what's this? Two old angels skipped over heaven carrying a harp. It's one. There's tons of different acronyms, or not acronyms, mnemonics. So I don't care how you do it, just memorize it. Sine of 40 gives you opposite over hypotenuse. So when you're solving for this, if you have a calculator that has a screen on it that types, that like you can see what you're typing, the whole thing, and edit it. Okay, you can just type it straight away like this: 5 times sine of 40. If you have a calculator that looks like this, that once you hit a new number in, you can't edit it, or your cell phone, you need to type in like this: sine 40. No, scratch that. You have to hit 40, then hit the sine button, and then times 5. Does that make sense? You hit 40, then the sine button, and then times 5. You have to do it that way. Okay? And the correct answer is A. Good? Okay. All right. Next problem. Call me over if this was a struggle, if you did not get on the previous problem 3.2. Right. You have an editable thing. So you can go 5 times sine of 40. And if you want it in parentheses, you can. It'll work without it too. Oh, you're in gradients.
I thought it was TRG.
Yeah, you went D.
Wait, what?
You went D. Oh, no. So you don't have to hit second. You just hit that.
Your calculator gives you the square root. Is that it?
Yep.
Or was it DEG?
Yep, degrees.
Okay, thank you.
Welcome. Anybody else not get 3.1? Folks, this skill right, what we're doing right now, you need to know how to do like for the rest of the school year. And for the rest of your academic life in math, and depending on your career, the rest of your life.
I know, but like I see like a line of 12 of them. They're all like
Olivia? You don't know who?
yeah. Like there's those.
Is their friends wearing green and they were
See, okay, now I know how to do it. So next problem, I got.
Okay. What sides do you have? You have hypotenuse and adjacent. Which are you going to use? Sine, cosine, tangent. Cosine. So you have cosine 75 is equal to adjacent over hypotenuse. Okay. A popular error would be to say cosine 75 divided by 2. And it's like, boom, 0.13. But then let's use some common sense. Is that possible for a side of the triangle, the hypotenuse nonetheless, to be equal to 0.13 when the other side is 2? Something happened. What happened was when you divide by 2, you're left with 1 over m, not m. Okay? So get that variable out of the denominator, please. Bring m over here. And then divide by cosine. So 2 divided by cosine of 75. That's going to give you something more realistic. Actually, like the right answer. Okay. Correct answer should be D. Good with that? Okay. What sides do you have? Opposite and adjacent. What are we going to use? Sine, cosine, or tangent? Tangent. Tangent of theta is equal to opposite over adjacent. We can do this. What is it? 0.65, is that right? 17 divided by 26, 0.65. Okay, is that our answer? No. We got to get theta by itself. To get theta by itself, we do something called arctan or inverse tan. Okay. So you have to do, so that is found by hitting second and then the tan button, or shift and then the tan button. Okay. Let me show you some ways to do this problem using a calculator that's going to make your life easier. You can either do, if you have one of these editable screens, you can type in this straight away. You can go inverse tangent of 17 divided by 26 in parentheses. And that'll get you the answer. Okay. You can also do this. somewhere on your calculator, and this is true for all calculators that are scientific. Let me, before I say that, check that. Oh, that's so sad. Really? Sad day. If you have this type of calculator, you're out of luck. You're just going to have to write stuff down. There's a function called ANS, brings back the previous answer. This is a great feature because what you can do is do this. You go 17 divided by 26 equals, and you get 0.65. Blah, 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 blah. Usually you'd have to write that down. But using this answer thing, it stores this answer. And so then you go, the next thing you go is shift or second tan. So tan -1, and then rather than like reading what you just wrote down, you just go answer button. So on this one, it's shift answer. That's above the little negative sign. And it recalls the previous answer. Hit enter, and wow, that's a lifesaver. Okay, good with that. All right. Without your calculator, just by process of elimination, figure out what the right answer is. You can do this because it's a multiple choice. And the triangle is not drawn to scale. Okay, here's how you can discern this. 45 degrees is like the halfway point. Okay, if you have a 45, 45, if this is 45, then you know this is 45. And these two sides are going to be equal to each other. That makes sense? Like the isosceles 45, 45, 90 triangle. Okay. If this angle is over 45, then this side is going to be the longer of these two sides. If this angle is below 45, this side is going to be shorter of these two sides. Hypotenuse is always the biggest, longest. Does that make sense? Okay, so the correct answer is C. Go ahead and verify that mathematically. Thumbs up when you got 9.9. Okay, so that's really all I'm teaching. If you're like, I need this review, I'll just run through a couple more of these just to make sure that we're tracking.